jiggles.
Okay, silence. Okay, way back in December, we did a packet. It was buff colored. In that packet, I had you do some things that were specifically designed to answer questions like what are appearing here. It says the graph of f is shown. Which of the following has the least value? Like, don't do most. That's least. This integral. Okay. When they give you an integral and they're comparing to Riemann sums, they are asking you to compare an ideal value to an approximate value. Okay? This integral, if we could compute it perfectly, it would find a value that is exactly equal to the area that I'm outlining in red. So this integral would equal, I'll just call it A, that red area perfectly. Please.
Isn't it actually just the area of 1 to 3?
Say again.
Isn't it actually just the area of 1 to 3, not 0 to 3?
Oh, I'll pay a pebble for that. You catch?
Nope.
True.
I can catch,
You get
though.
2 for being a good sport.
Oh, can't catch. She really cannot
Alright.
catch.
You want me to prove if I can catch?
No. Okay.
Steal all the cup plays up.
Can you catch a third ball?
Can you curve that?
No, but I can throw it in a way that makes it harder.
All right.
You ready?
As long as you curve it to me.
Good work. Oh, yeah. The video's running and everything. Okay.
It went through my hands.
Different color, please.
True. My bad.
It's okay.
You moved seats and forgot. Sorry. So really, this area in green. Is that better, CC? You good?
Yes.
Okay. That area in green, we'll call that area A. That would be the value of that integral. Question? Now, yeah, please.
That's going to be right in the middle, right? Of all these Riemann sums. Well, I guess like
It all
it's
depends.
going to be, at least if we're talking right and left, it's going to be an average between the two.
Something like that. You have exactly the right idea. I just can't quantify it to that level of specificity.
Well, not average, but it's going to be
Kind of in the middle, yeah. So now it says do a left Riemann sum with 4 subintervals of equal length. So you do this. You say I go to 1, I go to the left-hand side, I go right to the curve, and then I draw a rectangle like so. I would then repeat the process like so. 2 more rectangles. Questions? So the left Riemann sum is an overestimate. In this case, it changes depending on the problem. Question? So now I do a right Riemann sum, which means I would go here, I go to the right-hand side, draw the rectangles. So the right hand is an underestimate. So let's pause. Any questions? This is easy concept. It's very graphical. Most people find that easy. And it is tested a little bit. Not very much, but it's worth getting the point.
How do I know the difference between left and right with Riemann sum? I switched those up on this problem.
It's literally, the wording comes from looking at a graph. You go to the first subinterval.
Like which side, I guess?
You with me so far? You go to the first subinterval. Good? You pick the value of f, whatever you're integrating, on either the left or right of that subinterval.
Oh, so you pick the value of that.
Stay with me, we're integrating from 1 to 3, and we're integrating f. That means we've got to go find the value of f that is either on the left or the right of the subinterval. You understand? Have I answered your question?
I think so.
So, look. Here's the first subinterval. Right here.
Oh no.
Wrong color. First subinterval is right here. So if I go to the left-hand side of that subinterval, the value of f on the left-hand side of the subinterval is right here. And that's what I use, and that gets multiplied by dx. For a Riemann sum, dx is the width of the subinterval. I don't know if I've helped there.
Yeah, you did.
Okay. Somebody else? Please.
It's more of a, so like a right Riemann sum will always be less than on a concave down or decreasing graph. Is there any, like, in like vice versa for all the other use cases, is there any like instance where a midpoint Riemann sum, like or
So-
trapezoidal would be any kind of different? Because
Let me try and summarize what you're saying. Everybody listen, come on, listen close, listen. Okay. My opinion is that I like the pictures, I just think it's easier to remember, but what Brian is saying is absolutely true. Now be careful with the wording, because on an FRQ they'll test you on the wording. It's absolutely true that if f is decreasing, has nothing to do with concavity. If f is decreasing, then a left Riemann sum will always be an overestimate. Similarly, if f is increasing, then the left Riemann sum is an underestimate. It just switches for right. If you look at your golden notes, I have some notes that help with that. Look at your golden notes. Right over here, there's a box that shows the 4 different ways you're going to be asked to compute integrals. The 4 different ways. You're going to be asked to use your calculator, do antiderivatives with the fundamental theorem, use areas, and do Riemann sums. Then I have the note that Brian asked about. I wrote down, if f is increasing, the left Riemann sum is an underestimate. And then from there, you can just kind of come up with whatever rule you need. Matthew.
Whatever, like, how the similar question to this, but how it where it goes full Palkian down.
Never seen them do that, unless they made it obvious from your little sketch what was happening. You could do that. That wouldn't be that hard. To make an obvious sketch of, oh, I can see for sure what's happening.
Are you stealing my notes?
Next thing to memorize. I try to talk. Well, don't try. Don't talk when I talk. Cannot concentrate. The next thing to memorize is, if we're talking about trapezoidal, it's all about the concavity. So if you look at the golden notes back of the first sheet, there's some notes there to help you. Right here. Where'd it go?
It's right there.
Right there. If f is concave down, so f looks like this, when you make a trapezoidal sum, you're going left and right. So you're doing this, and then you're connecting, so that area you're finding cuts right below the curve. So trapezoidal, if the curve is concave down, the trapezoidal is an underestimate. Opposite for concave up. So I'm going to use that here. So when I do the trapezoidal, I'm going to get an underestimate, but it will not be as bad of an underestimate as the right Riemann sum, because it follows the curve more closely. Midpoint is very difficult to judge, but it tends to be kind of in the middle. It's not really high or really low either. The correct answer is C.
So the concept here, as I'm trying to think this through, is even without drawing or even, because what I did is I just thought that left and right are the least accurate. I just got to find which one's under. And I just circled that. I didn't even try and solve trapezoid or midpoint. It's just, is that a concept to memorize, that right and left are just tend to be the least accurate?
For the purposes of the AP test, unless they give something that's fairly complicated, I would agree that that is a very safe way to go.
Okay.
Something complicated, I'd have to stop and do some analysis. But for all the problems, yeah, all the things I've ever seen, they don't go that complicated. So your thinking is right on.
Okay.
That midpoint's going to be kind of in the middle. It is important to notice when trapezoidal is either an over or under. They will test you on that.
Yeah.
I've never seen them test you on midpoint being too big or too low. So.
Okay.
2 points.
Oh, nice.
Okay, I gotta pay Pebbles.